Assalamualaikum warahmatullahi wabarakatuh. My name is Nur'Afifah Binti Yousri and my matric number is CE180087. My supervisor is Dr. Wan Mahani Hafizah Binti Wan Mahmud. Today, I will present my final year project, which is an intelligent walking aid for elderly. For the introduction, this project was developed by upgrading an existing walking aid that can help elderly to move easily without tired and injured using a technology of self-balancing system. With the combination of chair, self-balancing system, and walking frame, elderly can move easily because they only need to sit and move their foot to make a movement in short or long distance. For the problem statement, for the first one is, senior citizen who's having a poor physical strength need to use a walking aid to move. The external body are becoming weak and not normally functioning. The concept of self-balancing in this project can make them more comfortable when using the technology. The design of the current walking frame was more difficult and exposed to danger for elderly. The poor stability of the wheels can make a bumpy effect when user use at the road surface and also making it easy to slip when facing a ramp. The implementation of the 4-inch wheels in this project are required to avoid from slipping or bumping when using it. And lastly, when using a walking frame, user hip joint was found to be abnormal when in the phase of stride cycle. During this cycle, hip joint was flexed because the design of standard walking frame made it restrain the extensor movement. To avoid an abnormal posture, this project will be used to infrared sensor that attach at front of the self-balancing device to make user easy control a movement using their foot. For the objective of this project is, for first one is to develop the hardware for elderly people to move using IWA device. Secondly, to design the self-balancing device that can be used in the both rough and smooth surface. And thirdly is to evaluate the effectiveness of the development system. The scope of project is, this project will be developed by upgrading the current walking frame to an intelligent device by using a self-balancing concept that attaches a current walking frame. The main component of circuit used is GD32F microcontroller and SIG MOSFET transistor at the PVC control board, a pair of gyroscope, a pair of wheels, and a pair of infrared sensor that located at self-balancing device. This project only focus on walking frame and self-balancing concept system that attach together for elderly users. Maximum load for external use is 120 kg. This is the block diagram of IWA device. There are sitting chair, self-balancing device, and walking frame that involved in the development of IWA device. In the self-balancing, it have a battery to support device to move. In circuit connection, it have a main board which is double-sided to PVC board that control the system of self-balancing device. It also have two gyroscope and two infrared sensor. Then it will connected to both wheels where each wheels have electrical motor that accompanied by tilt and speed sensor. Lastly, it will attach to walking frame. This is the component of the intelligent walking aid device. For the first one is sitting chair. The width of the seat highly emphasized to make sure user comfort and not fall when using IWA device. Secondly is a battery. The battery that used in the self-balancing device are lithium-ion power battery pack. The standard voltage of this battery is 36 volt. Thirdly is double-sided to PVC board. This board uses GD32F microcontroller as a main controller. It is to control the speed, wheels, tilts, direction of wheel spin, and LED indicator. Fourth is the gyroscope, tiny sensor that balances the board on two wheels. This sensor can keeping the balancing and upright at user. Fifth is an infrared sensor. It have a 3 layer to detect a movement. Top layer is a pressure pads, second layer is a switch, and third layer is infrared sensor. Infrared sensor can make user to control their movement when user took their foot in the condition lean forward on the pressure pads. Six is two wheels. It having an electric motor inside with the sensor, which is the sensor and speed sensor. And lastly is a walking frame. The walking frame that having design of rectangular because it more stable when it attached to the IWA device. Next is the connection of the circuit system. Control board that will control our system is 2 PVC board that connected to the battery and both wheels. Special design with GD32F microcontroller and SiC MOSFET transistor to move self-balancing device. Next, there are 3 output port from the wheels that will connected to the PVC control board where it will be send data from the wheels to the microcontroller. Fourth is the left side port. There is 8 ports that will connected to other components to make sure the system are function. The ports are auxiliary port connector, LED sensor port, LED side port, motor wire port, wire connector port, switch port and charger port. While for the right port are auxiliary port connector, LED sensor port, LED side port, motor wire port and wire connector port. For the battery connection, it have a 2 wire that connected to both control board when it have a negative and positive pin wire. This is the flowchart for the circuit work. When user feet on the board, user pad will detect pressure of the feet and switch. Under layer of pressure pad will push down. Then, IR sensor will allow user to control their movement direction when user took their feet on pressure feet. Next, the main board of the motherboard used in this project is 2 PVC control board. In the wheels, there are 3 important components which is electrical motor, speed and tilt sensor to make sure this device is functioning well. Both sensors used to detect RPM of the wheels which will send the information data to gyroscope and motherboard to control the speed. Then, it go to the gyroscope sensor where it will act to balance the device. Lastly, both wheels will move depending on user tilt direction. Next, this is the flowchart of intelligent working aid device. User have to turn on the self-balancing device which works as an input. Next, user must sit on the chair. Lastly, user must put their feet on the board that having a gyroscope and IR sensor to make a move. This is the assessment of IWA device. It doing at the smooth surface and rough surface. For the indoor, the smooth surface are tiles, the rough surface are carpet. For the outdoor, it will assess at the tiles and the road surface. This is the designation of the project for self-balancing device which having a front, top and right plane, working frame which having a front, top and right plane, design of steel part for the top view and sided view, and lastly for the full part of IWA device which having a front, top, right and left plane. This is the hardware of intelligent working aid device. There are sitting chair, working frame, self-balancing, steel and wheels. The testing of IWA device functionality. For the move forward, the hoverboard need to tilt forward where it can easily moving forward and can easy to control either want to slow or fast. To make a backward movement, user must down their both heel to make sure it tilt down so that they can move backward easily. To make a left move, hoverboard must pointing to the left. When feet touch the board, sensor will detect and follow the movement of the feet at the hoverboard so that device will make a move and turn left. To make a right move, hoverboard must pointing to the right. When the feet touch the board, sensor will detect and follow the movement of the feet at the hoverboard so the device will make a move and turn right. This is the assessment device for the IWA device and standard working frame. It has been tested at indoor and outdoor in the smooth and rough surface. The comparison between IWA device and a standard working frame, for the component, it having a 4 wheels, having a sitting chair and have a self-balancing device, while for the standard working frame, it having 2 wheels and no chair and self-balancing device. For the term of energy, it use for IWA device, it use a less energy, while for standard working frame, uses more energy. For the first surface at indoor, Smooth surface easy to move, while rough surface easy to move. For the standard working frame, in the smooth surface it easy to move, while for the rough surface on the carpet it hard to move. At the outdoor, IWA devices are easy to move in the both surface, while for the outdoor of standard working frame, for the smooth it easy to move, while for the rough surface which is at the road is not easy to move. For the conclusion of this project, the objective of this project are successfully achieved where IWA device can be used for elderly people to move. Secondly, IWA device can be used in rough and smooth surface, and the development of the system effectiveness had been evaluated successfully. And lastly, the system of self-balancing that was used in this project are double-sided to PVC control board. These control boards are using microcontroller and SiC MOSFET transistor to make the self-balancing function well, and it also connected with IR sensor, gyroscope sensor, and wheels. For the recommendation of this project is implement a manual brake to make users safer when using the device. Secondly, sitting chair are using Vespa motorcycle, which is high cost. Need to design and find the supplier that can deal minimum cost for sitting chair. And lastly, two wheels at the front. Make hoverboard touch the wheels when pointing to the left and right. Recommendation to improve the design of the front device is install the wheels more than 3 cm. That's all from me. Thank you.